Today's lesson we're looking at types of chemical reactions, and it's based on a grade 10 curriculum in Ontario, SNC2D, and we're just looking at specifically types of chemical reactions. Remember, a chemical reaction is when the properties after the reaction are different than before. Okay, and when you put something in, the things that go in are called reactants, or a reactant, depending on how many you have. So the reactants go into the chemical reaction, and what comes out are products or a product. Okay, it's either a product or products, depending on the chemical reaction. And if you remember from grade 9, in grade 9 you were looking at signs of chemical change, so something had happened, and so your first thing would be that light, heat, or another form of energy has been changed, whether it's given off or taken in, whether it got cooler or warmer. If a gas is released, so if you add something to a beaker and suddenly a lot of bubbles are starting to be released, that's a gas that's being produced. If the color changes, so if the color changes from when you add to, say, blue solutions and they change to a yellow or something totally different, that would be a sign of a chemical change. And the last one would be if there was a formation of a precipitate. And remember, if a precipitate forms, that means something in a solution all of a sudden became cloudy. So if a transparent liquid all of a sudden became cloudy, or there was little solid bits forming, that's what a precipitate is. Okay, so precipitation is there. Again, in a reaction, you have to remember that a chemical reaction, in the reactants, they have a set of properties, okay, whatever those properties happen to be. You might have a solid mixing with a liquid, or two solids mixing, or two liquids mixing, and those properties are set between the reactants, and then at the end you have your products, and the products have different properties. An example I like to use is if you burn a candle. So if you have wax burning, that's basically wax mixing with oxygen gas. And the products that are given off, you know it's a chemical change because there's heat and light being given off, but you also know that the products are different. And the products that are actually given off are carbon dioxide and water vapor. I'm just going to write water as H2O. Okay? So if you burn wax and oxygen, wax is a solid, oxygen's a gas. They're combustible. This is combustion. It's being produced carbon dioxide and water. If I put water on top of a fire that's wax, it's going to go out. If I put carbon dioxide on top of the wax that's on fire, it's going to come out, or it's going to go out, because carbon dioxide and water will both eliminate the fire, which is kind of cool because the properties of the combustion of wax would actually put out the fire. So that's kind of neat when you think about it. So think about it. Is there at least one sign of chemical change? If there is, then it's probably a chemical reaction, and what went in obviously have different properties than when they come out. So the next slide we're going to look at is types of chemical reactions. Look at is synthesis. And a synthesis reaction is basically taking two different things that have their own products, synthesizing them, and making a compound out of them. Okay, I like to use a high school dance analogy. So quite often when you go to a high school dance, two single people will go to the dance separately. They're separate entities on their own, and then they leave as a couple. In chemistry, that usually means they bonded together, and then they're in a more stable relationship once they've got together. Let's look at an example in chemistry. If I take sodium, wait, let's not use, I'm going to actually write it out. So let's take sodium, metal, okay, it's a solid at room temperature, and I'm going to mix it with chlorine gas, and I'm going to force it to react. Okay, so they're going to produce something. Sodium by itself, if you know about sodium, sodium is a solid at room temperature. It's very unstable. If you put it on yourself and you have any liquid of water on it, it would start to react. So sodium is not something you want to be dealing with by yourself. It's a dangerous metal. If I put you in with chlorine gas, that would also kill you, because sodium and chlorine gas on their own are both deadly to the humans, okay? But if I mix them and I cause a chemical reaction, I'm going to get something on the other side, which is an ionic compound, and that is sodium chloride. And sodium chloride, if I were to use that at home, I could put that on French fries and enjoy a nice salty French fry. So if you wanted to look at it chemically, that was sodium, because it's not Hofbrinkel, it's by itself. Chlorine, oh, chlorine gas, that's a Hofbrinkel. You're going to get Cl2, and you're going to make sodium chloride. And you have to remember back, okay, sodium chloride, what is that? Well, sodium, the ion, is plus, chloride is -1, so we follow those rules, and you make sodium chloride. So again, synthesis, you take one to another, and you form a compound that is one on the other side. Okay, so synthesis is like when two singles end up starting to date. So that's synthesis. Number two, the second type of reaction we're going to look at is called decomposition. And the decomposition reactions are just like when you think about decomposition in nature, or when you send something out to decompose, it breaks apart. Okay, so that's the breaking apart. And I look at a high school dance again, and I think, wow, some people show up at a dance as a couple, something goes on, and then they end up leaving as two individuals, and they've now broken up. That's a decomposition example. An example in chemistry, we're going to take mercury 2, oxide, and I'm going to heat it up, and I'm going to cause a chemical reaction, which then gives us mercury as the metal and oxygen gas. Okay, so if we go back to thinking about the chemicals that are being used, mercury 2 oxide, think back, okay, mercury 2, so that's Hg2+, okay, and then oxide is 2-, so I'm going to make that ionic compound, so that becomes HgO. And then as it breaks apart, it's going to form mercury. Mercury is Hg. Is that part of Hofbrinkel? No, so it's just going to be mercury. And then oxygen gas. Is oxygen Hofbrinkel? Oh, yes it is. So now we're going to form oxygen gas. So just to review, synthesis is taking two elements basically and making a compound of it. Decomposition is taking a compound and breaking it into two. Now there are two other types of reactions that we're going to specify in this lesson, and third type, and it's called single displacement. In single displacement, again, let's go to the high school dance and think about a couple that's there, and then someone else is very interested in one of the people from the couple. Usually there's a lot of drama that happens in this situation, probably a lot of tears, and then what happens is you end up getting a new couple and a new single person leaving. So you have a compound, typically an element, and then you get a different compound and a different element coming apart. Now, these are quite often, when you look at displacement, ionic compounds we're dealing with. Okay, so if you think of them as ionic compounds, if it's a compound and it's ionic, you're going to have a metal, which is a cation, and a non-metal, which is a anion in there. That would be your AB. And then the other one will either be the cation or the anion. So in the example that I gave up here, if it forms a metal ion, it's going to be positive. So what happens is the single displacement means they just switch spots. And so what you get is this forming with this, and that all by itself. So let's give an example. Okay, so let's take magnesium. And we're going to mix it with copper 2 nitrate. Again, oh, that's a polyatomic ion because it ends with the 8. And magnesium, so magnesium is at Hofbrinkel? Nope, so that's magnesium. And we're going to mix it with copper 2, which is Cu with the 2 plus ion. Nitrate is a 1 minus, so that would be NO3, 2. Okay, so looking at this, I'm just going to underline the positive, because magnesium, when it becomes an ion, would be positive. Copper is the positive ion, and nitrate is the negative ion. Okay, so when you go to form the, or predict what the products would be, these are basically going to swap places. So what you're going to end up making is copper all by itself. So copper is going to be out by itself. And what's forming? Magnesium, nitrate. Okay, and magnesium nitrate, pardon me, magnesium nitrate. Magnesium, if I'm trying to remember, is a 2 plus. Nitrate is a 1 minus. Therefore, that would be MgNO3, and there'd be 2 of them. Yes? Yes. So single displacement, again, switches things up, and one of the ions switches with another. Sometimes the replacement isn't always the metal, okay? So if I looked at another example here, and we took bromine, liquid bromine, Br2, and mixed it with potassium iodide, which is Ki. In the single displacement, bromine and the iodine are going to switch places, which will create KBr, which is potassium bromide plus iodine. So again, if you look, and I use the same colors, the potassium is the positive ion, and bromine gas and iodine are the ones that actually exchange this time. So it's different. So you have to be able to know what you're looking for when you do this. Okay? And again, single displacement, you have a couple at a dance, and then a single person, and then at the end of the dance, it's a different couple and a different single person. And the last is double displacement. This one doesn't often happen at a high school dance, except if it's just sort of for dancing and they switch partners. There was an old TV show that used to be called Wife Swap, and you basically have two compounds, A plus B, and another compound, C plus D. Sorry, let me change that. The positive ions are going to switch spots. Okay, so the positive ion A and C are going to swap. And what you get at the other side is AD plus CB. And you have to always follow, because these are often ionic compounds. If they're ionic compounds, you have to always follow the rules. Follow the chemical rules. The chemical and nomenclature rules. Do not forget, follow those rules. So let's give an example. I'm going to do, let's do lead 2 nitrate and I'm going to mix it with aluminum sulfate. Okay, so, and then you're going to say, oh, well, what gets produced? Well, lead 2 nitrate, so that would be PbNO3, right? Because there's two, lead has a charge of +2, nitrate has a charge of -1. Aluminum sulfate, well, aluminum has a charge of +3, sulfate is -2. We do that to make this aluminum, so you're going to have Al2SO4 3, okay? And let's look again. These are your plus ions, lead and aluminum, and your nitrate and your sulfate, those are your negatives. So, if you're thinking about it, these swap places. And if they're going to swap places, what are the products? So let's think about products here. Let's write them out. So if it's lead nitrate and aluminum sulfate, sorry, lead 2 nitrate, what you're going to get as products would be aluminum nitrate and lead 2 sulfate. Do you see that? Because lead and aluminum are switching places, the nitrates and the sulfates stay the same. So aluminum nitrate would be aluminum with a charge of +3, so you need 3 nitrates, so AlNO3 plus lead 2 sulfate. Lead 2 has a charge of +2, sulfate has a charge of -2, so it's PbSO4. Okay, so your products would be this. Hopefully that makes sense, okay? So that's double displacement. There is one other type of reaction that you should be aware of, is the combustion reaction. Okay, and combustion's a little odd. It's usually the production of heat using oxygen, and it's often a hydrocarbon reaction, hydrocarbon plus oxygen reaction. Okay, and the hydrocarbon is some form like methane, CH4, and you mix it with oxygen gas. The products when you do a hydrocarbon and you mix it with oxygen in the reaction is a carbon dioxide and a water with release of heat. Okay, so that's the other one. Hopefully this all makes sense. We'll do a couple of examples under here. So if I did a oxygen gas plus hydrogen gas forms water. Okay, so that's one reaction. Or hydrochloric acid, which is hydrogen chloride, plus sodium hydroxide. I can look at that and do a prediction on there. And I know that, well, look at this. There's a plus, and then a negative and a negative. So the pluses are going to swap places. And so what happens is I get NaCl being formed and HOH, which is also known as water, which is H2O. And one other one, let's do this one. Let's do AgNO3. When you look at it, oh, that's silver nitrate. And then I'm going to mix it with copper. And if I think of that, well, let's see, I've got a plus ion, and that would be a plus ion if it was an ion. And then that's a negative, so if there's 2 and 1, that would be single displacement. So it's going to switch spots, so I'm going to start making silver. Yes, it actually makes silver. And copper 2 nitrate. Okay, so again, this is single displacement. This one's a double displacement. And this is a synthesis. And hopefully that makes sense. And the next lesson we will look at law of conservation of mass and balancing chemical equations.